Hello, in this video we're going to look at the quasi-linear utility function and find the elasticity of demand from it. Here is our quasi-linear utility function. Got good x and good y. Beta is positive but less than 1. Price of good x is p subscript x. Price of good y is p subscript y. We want to solve for the price elasticity of demand for good x. We'll get the marginal utility of good x by taking the partial derivative of the utility function with respect to x. We get this result. We get the marginal utility of good y, and that is just 1. And we're going to set up the consumer equilibrium condition. Consumer maximizes utility by setting the marginal rate of substitution equal to the ratio of the price of good x to the price of good y, where the MRS, the marginal rate of substitution, is the marginal utility of good x divided by the marginal utility of good y. So the marginal utility of good x divided by 1, which is the marginal utility of good y, equals the ratio of the prices. And I'm just going to solve this for x. So dividing everything through by beta. And now I'm going to raise both sides to the reciprocal of this exponent on x. So doing that, we get this, and that is the demand for good x. You'll notice here income does not enter the demand for good x. To get the elasticity, we're going to take the derivative of the demand equation with respect to the price of good x, and then multiply it by the price of good x divided by x. So that's this result right here. So taking the derivative of this expression with respect to the price of good x, we're going to take this exponent, we're going to bring it down in front, so that's where that's coming from. And then we're going to subtract 1 from that exponent, so we got that. And then the rest of this, we've got the price of good x right here. And then in for x, what I'm going to plug in for x is just the demand for good x. The next step is to simplify this. So I'm just going to add up the exponents here on the price of good x and the price of good x. So we got these two exponents here. This is just price of good x to 1, and this is price of good x raised to the 1 divided by beta minus 1, all subtracted by 1. So doing that, this minus 1 will cancel, and we'll lose this price of good x over here. And then the next step is that this term and this term here will cancel. Okay, just got one divided by the other. And you're left with this expression. The price elasticity of demand is going to be 1 divided by beta minus 1. So if beta equals 0.5, the elasticity of demand, price elasticity of demand, would be -2. Okay, I hope you found this video helpful.